My pleasure to welcome you as a listener to my lecture. So, I will give you a talk about safety aspects of VVR technology. And my lecture has several training objectives. First, to explain the fundamentals of nuclear physics essential for nuclear safety and to explain fundamental of reactor physics. It's very important. Nuclear physics and reactor physics, they're quite different entities in the domain of technology. That's why I made a special stress on that. So the content of my presentation has four main segments. The first is about structure of the nucleus, second about binding energy, critical mass, and principle of nuclear reactors. Four segments, and this is all about nuclear physics fundamentals. So let me give you first introduction about nucleus. I would like to start this story from the very classical experiment of French scientist Henri Becquerel, dated 1900, that is just at the beginning of the 20th century. It is a classical experiment. Everybody from the school, they know about the essence of this experiment. It was an interesting story when he investigated the effect of the sun on the photo element. And once, it was not a sunny day, it was a rather cloudy day, he put the photo inside the table. And on the top of the photo element, he put just a very small piece of uranium salt. And next morning, he found that the photo element was blank. So it means photo element, photoplastine was damaged by something. If it was damaged by the sun rays, it was easy to explain. But he put the photoplastine inside the table. So no explanation from the existing at that time the laws of physics. He was a clever man, French scientist Henri Becquerel. He found by himself that he discovered something new phenomenon. Later on, this phenomenon started to be called the phenomenon of natural radioactivity. Later on, many scientists started to investigate the details of this new effect. I would like to stress the contribution of English scientist Ernst Rutherford. He made a very simple experiment, by the way. He put again uranium salt, but inside the condenser. Condenser means you have a negatively charged plastine and positively charged plastine. And he found that rays which coming from uranium salt, they may be categorized in three main categories. And by the way, that time there were no special words to nominate, to call for, to define this new phenomenon. That's why he put just the Greek alphabet letters. Those rays which are attracted to the positive plastine of condenser, they call beta rays. Those rays which are attracted to the negative plastine of condenser, he called alpha rays, and those which were not affected by the electric field, he calls gamma rays. Alpha, beta, gamma. So they started investigation of this kind of new phenomenon from categorization of the constituent element, alpha, beta, and gamma. And by the way, these three entities, alpha, beta, gamma rays, they have a different penetration power. Even school children know that alpha particles can be stopped by a very thin layer of paper. Beta particles, they can be stopped by a little bit thicker layer of substance. And to stop gamma ray, it requires a huge amount of very solid element, kind of concrete or lead. So later on again, they found that alpha particle, that's nothing more than just ion of helium. Beta particles is nothing more than electron. And gamma particle is not particle, but exactly electromagnetic wave. So that's very basic explanation of the natural radioactivity. With discovery of the alpha, beta, and gamma particles, humankind received a new instrument to study microworld, microsubstance. The first experiments with alpha particles were also performed by Ernst Rutherford. He just took the salt of uranium with alpha particles coming from this substance, and alpha particles impinged on the very thin layer of gold. And it was quite explainable that most of the alpha particles penetrates through the thin layer of gold without any effect. So the first results of this experiment was very simple. People knew that substance consisted of molecules. People knew that molecules consisted of atoms. So thin layer of gold consisted of atoms, and if alpha particles comes through without any deflection, means atom is empty. Atom is empty. That was first basic results of this experiment, also not trivial. Atom is empty. Atom is empty. There is one more very interesting conclusion resulted from this experiment. Some of the alpha particles, not many of them, maybe less than 1%, some of these alpha particles were redirected to the opposite direction. It was difficult to explain. So alpha particles moving to the thin layer and coming back. How to explain this? Atom is empty. Alpha particles should come through, but opposite direction. So they started to explain this phenomenon with the use of available at the time very famous laws of electrostatic. Everybody knows Coulomb law. So, and they found that if alpha particles, that is charged ion of helium, is coming in the opposite direction, it means the only one reason for that. That is repulsive electrostatic force. And after that, structure of nucleus started to be very clear. Atom is empty, but inside the atom there is a small, very small entity with positive charge. They call it nucleus. So, starting from this point, it was clear that nucleus exists in the atom. And I show you the typical dimensions of the atom and the nucleus. The dimension of the atom 10 to the minus 8 power centimeters, and the nucleus dimension is a 5 order of magnitude less, 10 to the minus 3 centimeters. Very teeny object, very teeny, very teeny. So that was the story of the discovery of nucleus, very simple. And in addition to discovery of nucleus, alpha particles played one more important role in the development of nuclear technology. Alpha particles, they started to be treated as a very interesting instrument to investigate the nature. I will show you in this slide just 3 aspects of very simple experiments. Alpha particle in vacuum. When alpha particle strikes the screens, there is a flash of light. So at the first experiments, by the way, were easy to implement, were easy to be implemented, and many scientists throughout the world started to open the era of nuclear physics. No big investment, just you can buy uranium salt, by the way, not so expensive. You have a dark room, you have a condenser, and you have a screen made of sulfide of zinc, and alpha particles striking the screen will make a flash of light. Just you not be like me with the glasses. If you have a good sight seeing power, without glasses you can count how many particles will strike the screen and make an effect. And if alpha particles strike the screen, it makes a flash of light. But if you put in the tube instead of vacuum some material, for example, gas, nitrogen gas. They expected, because of alpha particle has a very small penetration power, that alpha particle will be stopped inside the gas. But the experimental results showed the opposite effect. When you put nitrogen, alpha particle moving through nitrogen increases the number of flashes on the screen. People started to explain this phenomenon, and finally they got the point that flash of light on the screen was not initiated by alpha particles. This number of flashes were initiated by the ions of hydrogen. So that was another kind of revolution in the discovery of the microworld. It means that inside the nucleus there is a hydrogen atom ion. Because all the substance consists of atoms, and if from atoms, atom is empty, and if from atoms there is moving particles like ion of hydrogen, it means nucleus contains the hydrogen ions, and they call it just as a proton. Ion of hydrogen, they started to call proton, which literal translation from the Greek, ancient Greek language, means proto, number one, the reason of everything. So the main conclusion from the first experiments in nuclear physics was like that. Alpha particles can initiate nuclear reactions. If alpha particle strikes some nitrogen atom and strikes from this atom ion of hydrogen, means nucleus has been changed. And if nucleus has been changed, it means nuclear reaction occurred. So that was one of the main discoveries of the early stage of physics.